In this video, I would like to talk about Bordetellapertussis. Bordetellapertussis is a bacterium that causes whooping cough, which is characterized by a whooping sound when the person breathes in. Bordetellapertussis is a gram-negative aerobic Casobacillus bacterium, and it is non-motile, so it obviously doesn't move. The infection of pertussis, or the whooping coughs, used to kill 5,000 to 10,000 people per year before we had any type of vaccine. Now there's a very, very low chance that you'll die. Worldwide in 2004, around 18 million people were infected, and about 254,000 of those people died out of 18 million. As you can see, it's a very low chance nowadays because of the vaccine. Once again, just like the Streptococcus pneumoniae, this is why we get our vaccines early, and children, especially under the age of 1, get a full type of vaccination right in the beginning of their lifehood. So a little bit more interesting things about Bordetellapertussis, because we understand a little bit more, when I say we, I mean like the scientists that study this. They understand a little bit more about how Bordetellapertussis actually infects its host, how it gets in there. So it colonizes the lung epithelial cells, kind of like Streptococcus pneumoniae, except we actually know how it does it. There's a surface protein in the bacterium. It's a very difficult word to pronounce. I'm going to try it. Filamentous hemagglutinin, which binds to sulfatides that are found on the cilia of the epithelial cells, so the little hairs that are on the epithelial cells. Once it's on there and it actually attaches to it, the bacterium produces a tracheal cytotoxin. So tracheal meaning, like, obviously the trachea, or the basically upper part of the respiratory system, which stops the cilia from beating. Now this is a pretty important thing, because in our trachea, in our throat, as we know, there are the little cilia that beat, that move out debris and stuff of that nature. Well, when these stop beating, it sends the host into a coughing fit, because there's no way to clear that debris from the body. So now you're constantly coughing all the time and completely out of control. You can't, it's not like the coughs that you get and you can kind of, and then it kind of goes away. It's a consistently bad cough. And then these coughs they expel some of the bacteria in the air, which are free to infect other hosts. So as you can see, it's extremely contagious, just like a lot of other upper respiratory and lower respiratory diseases. It's extremely contagious, especially to younger kids. And Bordetellapertussis has the ability also to inhibit the function of the host's immune system. So two toxins, known as the pertussis toxin, or PTX, and the adenylate cyclase, are responsible for this inhibition. And adenylate cyclase converts ATP to cyclic AMP, and the PTX, or like pertussis toxin, inhibits an intracellular protein that regulates this process. So the end result is that phagocytes convert too much ATP to cyclic AMP, which can cause disturbances in cellular signaling mechanisms. So in layman's terms, so not only does it infect the cilia of the trachea, now we're talking that it's effectively suppressing the ability of the immune system to attack the infection. So phagocytes have absolutely no clues. So phagocytes, just a little bit of a background, is that they come in, they swallow up the disease that is trying to kill the bacterium, brings it in and kills it. Well, the phagocytes now, they don't understand. They don't think that there's actually even an infection going on. They have no clue, because, well, the immune system is now being not necessarily suppressed, but it's being controlled. It's being, the immune systems are responding, because now pertussis is attacking the immune system. So this brings it down to susceptibility. Unlike my previous slide, I'm going to just keep it into one slide. Susceptibility, now it's very important that we understand that this is most common in children under age of 1 because they're unimmunized, which means they just came out, they're not exposed to a lot of other things, they don't have a really strong immune system, and so it's very easy to attack it. That's why we get these vaccines right as early as possible in our life, and that's why it's very, very extremely important to vaccinate children at a young age, because if we don't, there's these dangerous things that can kill them. And it also really affects children with faded immunity, normally between the ages of 11 and 18. And the difficult part is that the symptoms start off looking like a common cold. You get a runny nose, you have sneezing, mild cough, low-grade fever, and normally 2 weeks after the coughing begins, they become extremely contagious. This is why we have the DTaP, again, diphtheria, tetanus, acellular pertussis immunizations right when you're a kid, because it would effectively stop this at a young age. So it's very difficult to understand, not be able to understand that this is why we need vaccines. So that is more of a thing.